Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I am your host, Dean Phillips, and I want to thank our sponsors, the Precision Metal Forming Association and the PMA's Educational Foundation, for helping us put this show together. I am so privileged today to have Bill Hickey here. He is here from Lapham-Hickey, where he is the chairman. Welcome, Bill.
Well, thank you, Dean. Thanks for the roaring applause on my welcome.
Well, we want to make you feel welcome right away. Get excited to be here, and our background applauders do their best.
Well, I am excited to be here. I think that the efforts you're trying to put out here about talking about manufacturing and about how really the destiny of manufacturing and how that's going to be good for everybody in the country, and how do we get there, and opinions like people like myself who've been doing it a long time. I think it's a great opportunity to get a conversation.
Thank you. So right off the bat, what is your biggest takeaway for things that are going to be changing or things that we need to do here over the next 5 years?
Well, I think you have several different points. First of all would be, policies that are in the government area, because the environment you're working within the government, if they raise taxes to 100%, everybody's going to be out of business. So you have to come back to, what are the policies on the fiscal and the monetary side, and also the regulatory side. And I think those are part of the issue of any growth in the economy. I think on manufacturing per se, I think in the metal processing and distribution business, the metal forming business, I think you're going to have a lot of opportunities going forward, because the technology is evolving, and the technology that's evolving is making us much more productive. And as I have said before, and I will say it again, is that manufacturing is a way of creating wealth for the people of the country. When you make something, when you make a part for somebody who's going to put it into something else, that whole process about where the metal came from, and where the raw material came from, and who turned it into the next stage process, and how that went through the whole system. All those, that's a way that everybody in that process has the opportunity to do something that adds value, and that value, they are be able to participate in that value, so that they are able to get some of the wealth creation. And as it comes along, they are be able to raise the standard of living for themselves and their family. And that's what people are looking for, is something that satisfies them, and also gives them the opportunity to live a better life for themselves and their family. So the technology changes are going to give people higher productivity, and higher productivity is going to give us the opportunity for people to have a better standard of living.
I think you hit on it there with one of my favorite words when people ask me what is great about the U.S., and I always say opportunity. That is the number one thing, is the opportunity that you have to succeed in our society is second to none. There's a lot of other countries that have other things, but there's no question that we provide the greatest ceiling for an opportunity to grow to.
You just look at the people who are, who've changed industries over the last 10, 15 years. They talk about, the people at Amazon. I mean, Amazon has changed a massive amount of industries. You talk about what's happened, you look at Tesla, you look at the genius behind that, and the SpaceX programs, and you talk about all the other changes that are really changing the works we do every day. The technology we have in our hands and our cell phones, just think about how that has changed. Think about the ability to be standing in the middle of a field somewhere and pick up your cell phone and get instant information on a global basis through some server farm sitting somewhere around the country, or maybe somewhere other country. I mean, this is technology evolution we have seen in the last 5 years is very, very high. And that technology is going to continue to evolve. And it's also going to evolve where it helps all the people with manufacturing. The Internet of Things is going to help. It's really going to drive quality. It's going to drive competitiveness, and it's also going to drive the ability to raise the amount of products we're going to be able to produce domestically because it's going to, all the other cost structures we have over the next 5 years, there's no question that there's going to be an effort to decarbonize the economy that's going to drastically change the cost of transportation, especially ocean transportation, which is going to really help the domestic manufacturing because they're going to get a much better understanding what the real cost is to bring a container from Asia into the United States.
Right. I think you're absolutely right, and I actually am looking forward to that being the case where we can focus on U.S. manufacturing. One of the problems that I'm always concerned with is that we didn't learn a lot last time we had issues. We had a problem when all the automotive manufacturers were complaining because the chips couldn't be supplied from Japan because of the tsunami and then the subsequent meltdown, the power plant there. And we said, well, this is never going to happen again. Well, here we are today, and it has happened again. But so I'm hopeful that this time it will actually ring true, that they will actually look towards finding a solution here stateside.
Well, I think you're right, Jamie. If you look at the global automotive production, Toyota had the opportunity to produce more units because they didn't do the chip arrangements that the U.S. domestic producers did. Certainly Toyota. I think they outproduced General Motors in the United States in 2021, and that was because they had chips. I mean, GM could have produced a lot more products; they didn't have the chips. But the Toyota relationship with their supply base, I think, is a little bit different than the GM relationship. And I think that because Toyota is where they are, and maybe because of the two issues you talked about, the tsunami and also the Fukushima meltdown, maybe they also, those lessons that they learned said, okay, we've got to have a much different supply base because we can't afford to, shut down our plants around the globe because of this. Now, they've had some interruptions also, but maybe if those interruptions were domestically in the U.S., it may have changed the way that the U.S. companies looked at that. I believe now that if they don't change it, then they are derelict in their responsibilities.
Right. So, Bill, tell us a little bit about your background, your family history, and what got you involved in manufacturing.
Well, I work for Lapham-Hickey Steel, which is a family-owned and family-managed steel service center. Started in 1926. It was started with my grandfather and two Lapham brothers. Yeah. February 1st, we started our 96th year. I came out of college, and I worked when I was in high school and college at the family firm. During the summers, at that time we had a place in Chicago, one in St. Louis, and one in Wisconsin. And actually spent one summer working over at Inland Steel in East Chicago, where I was working on the steel mill, which was really a wonderful experience. I came out, worked for the family business, and it was a much different time. It was a much different economy. This is, mid-1970s. After I was here a couple of years, my father passed away, and I had the opportunity to, all of a sudden get a lot more responsibility. It was not an opportunity I was seeking because of his passing, because he and I were very close. But, we have been able to maintain this as a family business. We now have a fourth generation who are the president, CIO, and also the chief commercial officer. And we have 11 locations now and about 750 teammates working. And we supply industrial products, and we also have some fabrication we do. We do all kinds of thermal cutting. We do all kinds of pressure cutting. And with the thermal cutting, we also do some bending and some other odds and ends, which has been something that our customers have come to us and said, gee, I'm buying the steel and doing this. We don't want to do this anymore. We want to buy the steel, but we want to really buy a semi-component part or something. And that's really how we've gotten in. That's really happened over the last 20 or 30 years. We've got a lot of OEMs who have tried to say, okay, if we buy a $100,000 or $500,000 or $5 million piece of equipment, we're only going to run it a couple of hours a day. Whereas if you have this capability, you're going to run it, 10, 20 hours a day. So that will make the cost of operating that equipment much, much lower. And those are the kind of realities that have happened, is that, if you're buying a very high-end piece of equipment and cost and also capability, you want to see if you can keep it running for a lot of hours on a daily basis. That'll give you much lower cost per unit of output.
Yeah, absolutely. I think that kind of goes back to, I worked at Niagara Machine and Tool Works, and one of the things that they learned was, well, I've got to find some way to keep that machine busy, to have that employee busy the whole time. Otherwise, I'm paying him just to sit there and not actually doing anything. So I realized at that point they were already starting to look at, how do we keep this, either number one, fill this job pipeline, or B, outsourcing the material, outsourcing the other aspects of it. And you see more and more of that. I have a friend of mine who works at Kenco, and which is a logistics company, and one of their focuses has been lately is they're asked to take ownership of the product earlier and earlier within the plant. So no longer just arrange for trucking. We want you to load it, and we want you to package it, and we want you to, earlier in the cycle, picking up ownership of that and handling more and more things. And I think you're on the other side, which is the supply chain side, which is, no, we don't want to just buy material. We want to buy material cut to a certain size. And like in Europe, a lot of that is sheet, which I've never quite understood. And maybe you can explain to me why Europe is very sheet oriented, whereas here we're very coil oriented.
Well, I think on that aspect that, you're seeing a change in the U.S. to do a lot of blanks and sheets because of the automation systems that are available, where you have towers that'll feed the press equipment or the lasers, whatever the either the pressure or the thermal cutting equipment, and then once the process is finished, it'll discharge the component part to a staging or a holding area or some area to be put away for storage or for the next process. But we're seeing a massive growth in blanks and sheets in the last 5 years, and this is really being driven by the technology changes on the lasers and the ability to feed them through systems or presses, either way. The tower systems that feed the machines, where you can operate lights out, and that has been a real change. We've invested a fair amount of equipment over the last, say, 7 to 10 years, and continue to invest in it. We just put a new cut-to-length line in one of our plants in the southeast. This is again to make blanks for people or sheets, where they taking it and the sheet sizes, they're probably going into a large bed thermal cutting piece of equipment, be it a laser or a plasma or whatever. And then on the blanks, a lot of those are going into presses that are just pressing a component part, and as they're doing that, they're probably putting a couple of holes in it also. So we're seeing a lot of that here. Now, I'm not exactly sure what the Europeans were, because very sincerely, Dean, I thought 25 years ago that everything would be coil to coil.
Right.
I mean, I thought, well, why would you want to have a sheet where you can, have somebody stand there and put it in there, where you can, mount a 10,000 pound coil or whatever it is and punch out, and there's still a tremendous amount of demand for coil, but there's really, depending upon, if you're going to do smaller batches, because certainly the flexibility of running it through a laser or running it through a press where you can, have a quick die change is much different than running some very, very large press where you're doing multi stages on a press, and you're making very complex parts. I mean, the tooling is so much different. I mean, the cost of tooling is so different than if you can, program a thermal cutting piece of equipment and say, okay, I'm going to put this in, and I need take this sheet and cut out 40 pieces, and I need 400 a night. So boom, we're going to cut 10 sheets. So it takes us an hour each. Boom, we're ready to go. And there's a lot of that going on that I've seen across it, because part of that is that the cost of, again, the technology cost of buying thermal cutting equipment has dropped relative to the time it takes to produce the part. So as you go through that, you say, okay, here's what it is. If I hard tool it, what's going to happen is I don't have a choice. I got to do the hard tooling. Or if I do some variable programmable piece of equipment that I can just it's got a different reality when you're doing thermal cutting. But the point is that there's a tremendous amount of lasers out there, and some of the new ones are just massively faster. The fiber lasers and the high wattages are just doing a tremendous job. Very quick production and also wonderful quality.
What are some of the opportunities you're seeing out there for some of the advanced technologies to be more important on the steel side? For instance, do you see more AI being incorporated into it, more IoT?
Yeah, you're seeing certainly on the production side where you're doing, with the domestic production capacity being massively increased right now as we're talking, where they're building 10 or 12 million tons of new steel mill capacity. The first one is a 3 million ton mill built by SDI in Texas. And these new steel mills, the furnaces, it's all electric furnace, so you have much more focused control on the batches you're going to make. So your ability to produce very specific grades of steel, very chemistries of steel, which will give you different physical properties once you go through the rest of the process, are certainly being created because of the technology that's available in this new electric furnace technology. So that's really going to be a real plus for, especially on repetitive sizes where you want to make a really repetitive grades, because the automotive industry is going to require more and more HSLA type grades so that we can have lighter weight cars, especially as we go down this road of trying to decarbonize the economy. So, and again, this is all going to be transmitted through, basically the internet as it goes from the different process functions and the manufacturing all the way down to how we, wind up making those component parts or producing the steel for the component parts into the tier 1 or tier 2 supplier.
Have you found that that there's more of a understanding of that and that they are adaptive to it, or do you still think there's some resistance to adapting IoT and more augmented or artificial intelligence?
Well, I think the artificial intelligence has to do more with your predictability on, how, basically in a kind of a job shop basis, there's, some capability. If you're doing actual manufacturing where you have a pretty good idea of what your demand is, you can probably use that at a much higher level. The Internet of Things, I think that's just a learning curve. I think that a lot of people, I know this is hard to believe, but in my life of working, I found times that people say, change is good as long as it's not me. So I think the Internet of Things is one of those things. It's change. And change is good. And I do believe that it will, continue to, because what it does is it gives you better information sooner. Mm-hmm. And that's really a key to what you want to have. Why do you want to have a report when you can get it on a screen? I mean, it's one of the things we're trying real hard to do is to automate some of our processes so that, some of the people have, basically, handheld computers where they can look at and, add information, talk about where they are in the process, what are the results of, the measurements they're doing. Okay, how does that compare to what they have to do in where the customer is real time? That's what we're trying to make sure we have. And then have that information captured and reportable, which is why you wanted to have it in the Internet. So you could, once you created it that way, you've got it forever.
Yeah, that's a great point. Have you seen much of a change and an appreciation for kind of that 5-year goal plan of what do we need to get to be there, in 5 years? What are some of the things? You talked about more of the HSLA. Do you see an acceptance within the stamping industry and within the forming and fabricating industry to adapt their machinery to this? Because I know certainly you can't just say, I'm going to use the same tool that I've been using on mild steel. on HSLA?
Well, that's a great question, because I would have answered this differently a year ago than I'm answering it today. First of all, because I'm not sure what has driven automotive material technology and chemistry changes because what you're looking for is thinner, more strong strength. You're looking at thinner product, higher strength. I keep wondering, this was designed because of gasoline, internal combustion engines. Mm-hmm. So we're going to consume less and less of the fossil fuels that generate gasoline or diesel, whatever. I don't know how you handle that when you have a battery car, because a battery car isn't going to know, your physics on the battery are so much different than they are on an internal combustion engine driven vehicle. Do you really have to how do you have a corporate fuel standard? CAFE, which is what's driving a lot of these, and the Biden administration has just drastically raised the CAFE rules again. But how do you have a CAFE standard when you've got an electric car? Mm-hmm. I don't know how you measure it. So you come back and say, well, you got to have 45 miles per the gallon. Well, I'm not using any gallons. I'm plugging it in my garage, and in the evening I walk out and I'm not sure if that doesn't change how you look at the materials going in there, because the material requirements in a battery operated vehicle are substantially different than they are in an internal combustion engine. Well, your transmissions are totally different. Your drive, there's a whole bunch of stuff that this doesn't. And so you're gonna lightweight that vehicle massively, excluding. I don't know what the battery is going to weigh. Mm-hmm. Because that's going to also depend on what kind of mileage and what kind of distance you're going to have with the battery, and that comes back to the other side of it is that you're going to wind up with some kind of, I'm sure at some point, some kind of regulation on the batteries, and I don't know how you're going to regulate the batteries, and I don't know how you're going to compute the carbon footprint of charging your battery every night.
Right, and you still have to maintain roads and all of that, and
sure.
A significant portion of that is through taxes on fuel. So what is the tax on fuel? Is it going to be an electric tax now? Is it going to be, that's
great questions. You're really going through a transition of, this is basically going from the horse and buggy to the horseless carriage, mm-hmm. but it's now the horseless carriage, which is not, and what drove that was the internal combustion engine, because you could put a tank of gas in the vehicle on it and just, you could, go, and you could run the vehicle until you ran out of gas. Well, now you're going to do the same thing, but it's not going to be gas. It's going to be a battery charge. And again, I just don't know. The battery numbers are really small so far. You're doing about 400,000 or 500,000 sales a year on battery cars in the U.S. You've got, last year I think they did about 12 or 13 million. The scale on this thing, Dean, is, we've done some research on this, looking at it. There are 275 million vehicles registered in the United States. Hmm. There's more registered vehicles in the United States than there are people who have driver's licenses.
Right.
And this was as of like 2020 or 2021. It's a simple thing. You go to add the states up. Well, it's going to take you a long time to change over the fleet.
Yes.
We can produce maybe 600,000 battery cars in the U.S. every year. You're probably, the fleet is about 13 years old. It's going to take 25 years to turn the fleet over.
Yeah.
And I don't know how this evolves, but at some point it's going to evolve differently than we assume. This is one of the problems of having a 5-year plan, when the reality is that the politicians at some point can change the whole plan.
Yeah, that's right. It is their plan to kind of maneuver and manipulate to a certain extent, and that will impact how we're doing things, and which is always amazing to me when you see politicians go in and say, all right, we're going to put this standard in place next year. Okay, it's going to take more than a year to really make a significant change, and in order to comply, a lot of times it requires a wholesale conversion to something. And it isn't usually that easy as opposed to something that's phased in.
Well, and you come back to one of the ones that's an example right on the table now, because I read something about it in the last couple of days, is charging stations.
Mm-hmm.
Part of the infrastructure bill that the House and Senate passed a few months ago and the president signed was, there's some stuff in there for infrastructure. One of the points is the federal government is now through that going to subsidize charging stations. Well, there's a domestic content on that, and in several of the states have said, well, we can't find charging stations made in the U.S. Well, I mean, first of all, there are charging stations made in the U.S. There are a couple of people who are making it. But, the bureaucrat in the state of New Jersey or whatever it was says, well, I can't find them, so I want to buy them in China. So I need an exclusion to buy them in China. So you're taking federal tax money, which we don't have, which we're borrowing, and right. Sooner or later our kids and grandkids are going to pay. And we're going to take that money and we're going to make sure that the charging station industry in China is really in good shape. I mean, this is crazy, and it's not like we have 30 million electric vehicles on the road. So what you have to do is you just came up with your comment, we have to slowly bring it. Okay, we're gonna start buying charging stations. Okay, what's the capacity? And we have a customer in Chicago that makes them. Okay, so how many can they make a year? Well, who else is in that industry? So let's get somebody in the Department of Commerce or the Department of Transportation let's get them to go out and say, okay, we want to know who's making this. We want to see what the standards are. We want to make this a domestically produced product because we don't want to have the problem with charging stations that we're having with chips.
Right.
So let's figure out how it is. I mean, this is not rocket science about how we're going to charge cars. So this is what we have to do. We have to once you make these laws, as you so rightly pointed out, once you make these laws and say, okay, we're now going to have all these electric cars, and we have the federal government go out, we're going to pay all this money to put charging stations out there. Well, then we've got to have a plan of saying, okay, how do we make sure that we have charging station capacity? Okay, well then we'll start saying, okay, here's an award for 100,000 charging stations. Where are they going to go? Who's going to get them? And then then people say, how many? Well, once you get to some concentrated number, what happens is that okay, then you don't need all that capacity. So you ramp up to make 40 million a year, and then the next year you don't need any. So the point is you've got to come back and use this reasonably well and start thinking about, as you do these changes, you have to talk about the holistic reality of if you're going to go to an electric vehicle standard, then we've got to talk about how do we have a charging system, how do we talk about the grid itself, and all those types of products. But this isn't what happens. We get something passed and everybody says, oh my God, I got to go to China to buy the charging station. They don't have to go to China to buy a charging station. There's plenty of places here, but let's make sure that the Department of Transportation starts saying to people, okay, we need more charging station capacity. Here's what we're going to do. We're going to have the capacity to make 400,000 a year. So what it is in 4 years, we're going to have the capacity to do 600,000, whatever the number is. But at some point, you get saturation.
Right.
And that's one of the problems you have, that you don't want to have. It's personal computers. Do you remember the days when we had 100 personal computer manufacturers in the U.S.?
Yep.
Well, there's how many are not left? 2?
Yeah, there was. I remember the days of the Sinclair.
Well, I remember the gateway with all those boxes that had they looked like cows.
Yes, that's right. And that's a very good point. And we tend to consolidate things because we can't. The infrastructure cost within something is significant. Talking about having a machine that's underutilized or even an employee that's underutilized. If you don't have something for them to do, then that's a problem. So how do we have the right infrastructure to maximize our use for these types of tools within technology? And even thinking about steel, how do we maximize our use of steel so that we're meeting the demand here in the U.S. so that we're not as reliant on imported steels?
Oh, another great question. On the steel industry, the United States is by far the only large, industrial company that has, a fair amount of imported steel. And basically, there's very little in a lot of the European. Some of the European product comes out of Asia. And of course, the Chinese are the gorilla in the room on this whole discussion because of their massive amount of steel capacity they've created over the last 20 years. But the U.S. Will be one of the things that was just negotiated. It was the U.S. has negotiated a tariff rate quota system under the 232 umbrella with the European Union, and part of that agreement is between now and the end of that agreement, which lasts until the end of 23, is to work on how do they look at steel industries globally that are highly polluting, high carbon content, et cetera. The United States industry, because about 80% of the production in the U.S. is electric furnace, it is by far the cleanest steel producing industry in the world of any major size. And it's going to be much cleaner because the capacity that's been been under construction or been announced for construction over the next several years will all be electric furnace. And at some point you're going to take away some of the more polluting, environmentally challenged products of coking coal and blast furnaces and those types of processes that just by their nature have the opportunity to put more carbon, have bigger carbon footprints. So what you've come back to is, as you look at this, the steel industry in the United States, really has to work on, making sure that the message is out that we are the cleanest in the world. Why are we subsidized? Why are we bringing in products from countries that have very, very bad, carbon footprints? That's what we're trying to do is come up with a system of how do we lower global warming, et cetera, which is certainly what seems like what's going to happen globally. So how do we do that? Well, the first thing you have to do is look at the people who have big carbon footprints. The largest carbon footprint in the world is China, by far. It's not even close to U.S. U.S. isn't even close to the Chinese carbon footprint. And, and we are a massive buyer of products out of China. Should there be some type of carbon tax on everything that comes out of China to the United States, so that we would then have those industries in the United States, because they wouldn't be having to fight the mercantilist policies of the Chinese government?
Well, historically, we haven't done that. I mean, if you look at steel tariffs and things like that, we haven't. We do it on the raw materials, but we don't do it on the end product. So if you're there's a lot of hidden costs in some of those things, and I'm not sure what do you think is a good way to approach some of that, because we do struggle with raw materials versus end goods.
Well, I agree with you. I mean, as long as I've been in this, we've been trying, as there have been trade actions brought under U.S. law because of subsidized steel production around the world that was being dumped in the U.S. We've always gone to the discussion groups in the Department of Commerce and the United States Trade Representative and said, if you put a tariff on steel products coming in the United States, you really have to put a tariff on steel-containing goods coming in the United States that's correspondingly somewhere relative to the tariff of the steel itself plus a fabrication margin. I actually had a conversation with a Secretary of Commerce on this back when President Bush II was in, and was Secretary Evans, and Bush was doing the steel thing right before 9/11. He was doing this, and literally we were in a room, and it was a very nice conference room in the Commerce Department, and he basically laughed at us and, well, that'll never happen. And we said, well, then it's not going to be successful, because what you have to do is that, if you don't have the corresponding cost of the product, the true cost of the product in there, what's going to happen is you're going to lose more manufacturing consumption over time. And that's one of the things that you have to do. You have to come up with, truthfully, what has to happen is, we have to have some type of competitive strategy for countries that are going to try to run mercantilist policies and dominate specific manufacturing areas.
Yeah. Technology, how do we leverage some of the technologies to be more competitive with some of the countries that are let's say, behind us technology-wise and behind us in manufacturing skills. A lot of times, I think, and mistakenly so, people often will think of China as, well, they just throw labor at it. And I think that's really not a fair comparison, because a lot of their plants are very high-tech despite a surplus of labor. They do throw a lot of money into technologies as well. And how do we leverage our technologies to be more competitive?
Well, the largest customer for high-tech manufacturing equipment out of Germany is China. Mm-hmm. I mean, your comments about having very high sophisticated technology plants in China is very true. I mean, they make a tremendous amount of technology equipment there. They make basically all the PCs and tremendous amount of phones, portable phones. Those are basically all made in China. Those are made in very high tech factories. They are made with people standing there. I mean, truthfully, in those operations, the last thing you want is people. They're all done with machines because the people will screw it up, and so it's very difficult to leverage technology, because technology is so easily taken from one country to the next. There is very small windows of competitive advantages on technology change. I mean, they're really small windows. Mm-hmm. If you have a massive technology change, that's one thing. But what you have now is incremental technology change. You're able to go from 100 units an hour or a minute or whatever the standard is to 120 or something. So you have incremental, but a 20% incremental productivity change is huge. But again, those are incremental technology changes. But the globalization of manufacturing over the last 30 years was, the design was that, everybody would have their standards of living raised. Well, that really hasn't worked, because the parts of the United States have not had their standard of living raised, because their jobs have been all taken by people who wanted to have industries where they could have, make the products and export them in the U.S. So the technology evolution is something that we have to use, because it makes us more productive. And the other cost structures that are in place in order to bring products here, especially products that are incredibly bulky, the cost of getting something on a boat in China, or putting it in a container, bringing it into LA, putting it on a rail car, taking it into Memphis, taking it off the rail. I mean, these are high cost operations, and those costs are not going to go down.
Right.
So what happens? You have to have the ability locally to make the components. It's your comment back about the automotive production and the chips. You have to have the ability to make. You have to have enough flexibility in your manufacturing base, and you have to have the technology in your manufacturing base, so that you can have the flexibility to change and make other components if you have to, because of the global sourcing issues.
Yeah, and that's something that we're certainly addressing now. We're definitely struggling in almost every area in manufacturing, because of waiting on ships getting in and waiting on materials, and it's definitely an issue. Not to mention our challenges with workforce right now, the shortages that we have.
Well, one of the ones you just mentioned was materials, and just there are niche materials, small volume products, steel products, aluminum, all materials, copper, brass, that were in specific industries, and a lot of the end-use consumption of those products in those industries have been offshored. And then what's happened is you've lost the capacity for those products in the United States. That is a problem. And that problem, I think of things like alloy bars, cold drawn alloy bars, which are, needed because of their really good wear life, and they make a lot of products that have, something that you need a lot of wear life on it. Well, it's real tough to find that stuff today. And the light gauge flat roll, you getting light gauge flat roll, that's very, very difficult to find, because the products that are made out of that have been already, the end use markets are gone. And there are some end-use markets, but the major ones, which were basically, consumer durables of some type, the consumer durable production has been moved to Asia, basically China. And those are the type of things that the Department of Commerce and the Department of, Labor and all those people have got to sit back and say, strategically, we really need to have the ability to do this, because if we don't have the ability to do this, we are going to lose the capabilities to produce these products. And that's the kind of thing that, it's tough to come, if I don't want to come up with a centrally planned economy, but you also have to have a system of saying, we need the capability to do this, and that's a problem. I think part of it has to do with, when you can subsidize everything that's coming out of a country, which what China does, everything is subsidized through their currency. Until you do something about the currency, the reality is you're going to continue to have this whack-a-mole problem we have of, okay, we're going to do a tariff on steel, we're going to do a tariff on this, we're going to do a tariff on aluminum, we're going to do, there's no competitive reason why the Chinese should be the biggest solar panel producers in the world.
Right.
They have no natural competitive, what they have is they have a lot of government subsidies and they have a really cheap currency.
Mm-hmm. I think you hit it on the head. Cheap currency can make you competitive in any market.
That's what it is. And, the Chinese devalued their currency 30-some years ago. They devalued it by 80%, and, it's nowhere near what it was then. And they now have this massive mercantilist system that, and then you look at the initiative they're doing in Africa, where they're, basically, building all these, airports and railroads, et cetera, and then they're basically enslaving the people through the debt service. So a lot of interesting things going to go on over the next 5 years. A lot of it's going to have to do with the geopolitical reality of where's China going. I mean, that's one of the things that I sit up at night and worry about, because the Chinese they've eliminated the two-term on the president. Xi is basically becoming the new emperor, and that's very scary because one of his overriding goals is to bring Taiwan, the breakaway province, back in. Mm-hmm. It's a real problem for the geopolitical realities of the next 5 years.
Yep. Well, sir, we are just about out of time here. Thank you so much for being here today, Bill. We really appreciate it. And thank you for all that you do with the Precision Metal Forming Association, who is also our sponsor here. We really appreciate them and appreciate you, sir.
Thank you, Dean. Thank you very much for the opportunity.
Thank you.
Bye-bye.